As we continue our journey towards understanding how atoms bond with one another to form a variety of different compounds, we begin with where we left off, and that's with electron configurations. So here I have, I quickly put out an electron configuration for sodium with 11 electrons and another one for chlorine with 17 electrons. And remember, one of our key words is this idea of what are valence electrons. And the valence electrons are those electrons in an atom that are in the outermost energy level, and we're focusing in on the outermost s and p orbital shells in those areas. And so when we look at sodium, sodium has 1 electron in the 3s, and chlorine has 1, 2, 3, 4, 5, 6, 7 electrons that we call valence electrons. The 3s is full, and there's 5 out of the potential 6 electrons in the 3p. And so what happens when sodium and chlorine bond together to form sodium chloride, which is normal table salt, is sodium actually gives away this electron, and the chlorine atom takes it. And then what you have is you have sodium, which becomes an ion, and now it's a positive 1 ion because this electron is gone. And then chlorine is an anion, a negative ion. It's a negative 1, and that's because it has that extra electron. And you want to remember and note that neon, which is a noble gas, has 10 electrons, and when sodium gives away an 11th electron, it certainly does not become neon, but it does have the same electron configuration as neon. And if you look at the chloride ion, it has now 18 electrons. And if you look at your periodic table, the element with 18 electrons is also a noble gas, argon. And we do know that those noble gases don't react with things because they have that stability that comes with an octet, or 8 electrons in the valence shells, or the outermost energy level. Today what you're going to be doing, if you look at your homework sheet, is you're going to be writing what's called Lewis structures, which is another way to look at those valence electrons by drawing symbols and using dots for the electrons. And you can see that I took this from a middle school lesson, so you can be confident that you will be able to do this with very little stress. The first thing you do is find the element on your periodic table and determine the number of valence electrons. Well, certainly we can draw out a full electron configuration for each of these and look for those outermost s and p electrons, but there is an easier way. And if we look at our periodic table, we can be reminded that we have this S section, we have our P, we have our D, and we have our F. And if we focus in on just the S and the P section, we can look at the columns on the periodic table, and if we count them, we have 1, 2, 3, 4, 5, 6, 7, 8 columns in that S and P section, which we often refer to those elements as the representative elements. And each column is called a group. We sometimes call those groups families because elements in a family have similar properties. And each element in that group has the same number of electrons in their outer energy level, which means those valence number of electrons are going to be the same for the elements within a group. So if we count those groups and we label them 1, group 2 has 2 electrons, group 3 has 3 electrons, group 4 has 4, group 5 has 5 valence electrons, group 6 has 6 valence electrons, and our noble gases, they all have 8 valence electrons. Is the fourth group in reference to the valence electrons. So we have 1, 2, 3, 4. So what we do when we draw a Lewis dot structure, or Lewis structure, is we write the element symbol. Carbon is our first example. And we look at its location on the periodic table, and it is in the fourth group. And what we're talking about and here we have carbon with 4 valence electrons. So we start at the right, and we draw in our 4 valence electrons going counterclockwise. And you can see your worksheet has a guide at the top of the page that you can follow when you do that. Then you check your work and double check to make sure carbon is in the right spot with 4 valence electrons. And then we can look at this worksheet and we can do some of these that are suggested here. Hydrogen, 1 electron. Its Lewis structure shows the 1 electron on the right. Phosphorus, you look that up on your periodic table. And you'll see that it has 5 valence electrons. 1, 2, 3, 4, 5. So those dots are representative of those 5 valence electrons. Please note that what it's showing here is 2 paired electrons and 3 unpaired electrons. This is similar to the extended version where we chart out the entire electron configuration, only now we have something that's concise and we're seeing 2 electrons paired and those 3 unpaired electrons. Calcium, 2 electrons in its valence shell. We draw the Lewis dot structure like this. Argon, it's a noble gas. 8 valence electrons. Go around clockwise second time. And then we're doing chlorine, 7 valence electrons. Okay, it's a lot nicer and neater than our big drawings with our arrows for representing electrons in the different orbitals. Aluminum has 3 electrons. And following this pattern, you can complete your worksheet. Once you get the worksheet done, I want you to notice the similarity of any of our groups. As you look at your groups, you're going to see the pattern that those Lewis dot structures look the same. I also want you to begin to project and think about some of these atoms, we have the Lewis dot structure for fluorine. My dots don't look really good there, but, and so what we have here is we have 7 out of the potential in the valence area for 8 electrons. And what's going to happen when fluorine bonds? Well, fluorine is likely going to take an extra electron and fill up that position. So fluorine bonds in order to mimic the electron configuration of neon, which has a full octet. And that's where we're going with this, but seeing Lewis dot structures is going to be something that'll happen, especially when you're reading the textbook. Although we don't spend a lot of time on these Lewis dot structures, I think it's very valid just to take a lesson and look at those and become familiar with drawing them, because it's pretty easy. Now, when you do your second worksheet, you're going to be working again with the element, and then how does that element become an ion? And remember that when an atom becomes a cation, which is a positive ion, it does that by losing electrons. Getting ahead of myself here. And then, of course, a negative ion, anions, they gain electrons to get their charge. So you want to remember that when the ion becomes negative, it's going to gain. So fluorine here, it has that atomic number of 9. Is the atomic number going to change when it becomes an ion? Absolutely not. But the number of electrons is going to change. It's just going to gain electron. So when you do your electron configurations, you're going to add that extra electron in. And then again, when you show your Lewis dot structure, the Lewis dot structure now for fluoride, the ion, is going to have 8 valence electrons instead of just 7. So this worksheet, you're going to be looking at both the atom and the ion. Please note that when we talk about the fluoride ion, when fluorine becomes an ion, negative ions, we give them a name. We change the ending of that name to IDE to refer to the ion. You'll hear more about that later. And again, for calcium, if it's a positive ion, what happened? It's going to lose electrons. In this case with calcium, it's going to lose 2 electrons. Is the atomic number going to change? No. But the number of electrons changes. So I think you're going to find that this is pretty easy to do. You should be able to complete this worksheet. And then when you work on the third part of the assignment, that's going to give you another opportunity to see these patterns, and the repetitiveness really is going to hopefully drive that point home and give you the opportunity to predict how a element will bond.